Okay, this is going to be Sierpinski triangle project done in Racket. So let's get started. Let's go to the desktop and start up a new file. Sierpinski.racket, like that. Okay, great. Let's maximize this. Make the font a little bit bigger. Maybe too big. Okay. Now let's put a title here. Sierpinski's triangle. What is Sierpinski's triangle? It's basically Pascal's triangle. It's the same thing as Pascal's triangle, but colored. You know, it's a graphic, colored. It's a graphic. It's actually a fractal. And this becomes obvious, it becomes clear that it's a fractal when the number of rows goes to a big number, as we're going to do like maybe 128 rows or more. And you'll see that it has this fractal nature to it, and that's what makes it so interesting. So basically the idea is like this. The odd elements of Pascal's triangle, binomial coefficients, they get colored, let's say green. And the even elements, they get colored blue. I think that's a good color scheme. I've tried that. It looks good. And we can't just naively start with a Pascal's triangle and do like that. It's not going to work. We have to compose our graphic carefully, okay? We have to compose the graphic in a sensible way with a background and all of that. So let's do that. So I'm going to work on a 13 by 7 background array or matrix of squares, background squares. You'll see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, let me copy this row and I'll show you what I'm gonna do here. All right, 1, 2, 3, 4, 5, 6, 7, 8. Okay, I think I just need 7. Okay, so this is going to be row index k is 1, and this here at the end, let's count. K is 1, K is 2, K is 0, sorry. We count from 0 because we're computer scientists here. 1, 0, 1, 2, 3, 4, 5, 6. Okay, here K is 6. And this is going to be total length, or the last, total length is 7. The last row of Pascal's triangle is going to be row 6. All right, the row that begins 1, 6. Now, 0 is our background. This is a background square. We're going to make squares using the Racket graphics module a little bit later. And 0 is going to be a background square, and that's going to be black. And we're going to color an odd, well, that's going to be green, as we wrote above, and our evens, this is going to be blue, like that. All right, we have to embed Pascal's triangle into this, so let's try doing it. You can make it look really good. You see, if we let there be some background like that, right in between the elements of Pascal's triangle, it's going to look really good. Okay, like here, 1, 2, 1, like that, okay? And then here, let's keep going. Let's construct this whole thing, okay? 1, 3, 3, 1. You know, if you construct it some other way, it's not going to look as good. The triangle's going to be too thin. This is going to look great. You'll see why we need the background also, okay? And you'll be able to do your own variations. Now here, 4 and 6 adds up to 10. That's too big. You know, 10 is 2 digits. It's not going to look good in this rectangle I'm building here. So let's just call that x. It's going to be represented by a colored square anyway, and all colored squares are the same size. All squares are the same size. That's my design, okay? Let's continue. That's 5, and that's a 1 here. And let's continue here. 1. Okay, this is going to be row 6, you see? K is 6, row 6. And this is a big X. This is actually 20. And here, big X. And this is 6 over here. Finally, 1. All right, let's analyze this a little bit. Okay. You notice the structure of this thing. Okay, 1, 2, 3. 1, 2, 3. Let's go back. 1, 2, 3. I have a row of Pascal's triangle with zeros interspersed. So I need to construct that. Construct row of Pascal triangle with zeros interspersed. Now that's one of our first tasks. We're going to do that by recursion. And here we have these zero paddings. The left and right is the same. Here it's 4, here 3. So what's the pattern here? Well, look here. If we have 6 minus 2 here. This K is 2. 6 minus 2 is a padding of 4. Yeah, right. So the idea is n minus k gives me padding of zeros of 4. Okay, so in this case, so n minus k, that's my padding. And I have to put it on both sides. You see, look here. Here I have 1, and here I have 2. That's really easy to do. If you work with lists, you'll see. So my second task, so task number 1 that I'm going to do, construct row of Pascal triangle with zeros interspersed. Second task, construct zero padding lists. And then we're going to be able to then construct rows of the this thing above here, this rectangle above, the rectangle above. Okay, so that's going to be our job. We're gonna get to work on this. So the first thing we need here is to import some Racket modules. Well, we have to also put the Lang Racket line like usual. And now let's import some Racket stuff. We need to require math number theory. Why is that? I'll tell you in a minute. And the pict module. Okay, what do we need math number theory for? Well, I mean, I can write my own binomial function, but I don't want to do that. I want to use Racket's binomial function. I'm lazy. I don't want to write my own right now. Now for pict module, we're going to take from pict module some functions that are really cool. Colorize, filled rectangle, and HC append. Here, let's keep going here. Let's make it look nice. HC append and VC append. I'll show you how to use these things later. For now, let's just see. For now, what does binomial do? All right, let's load up Racket. I'm going to work on screen split horizontally like this for the moment. Okay, let's try binomial. You ever play Lottery 649? So from 49 numbers, we choose 6. There, 13,983,816. Famous number. Okay, let's go back to work here. If we go back to our matrix here, let's add a bit of comment here. Here we can put a counter variable. Here counter is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you see the counter, let's call the counter I from 0 to 2n inclusive. Yeah. So that gives us the clue for writing our function that we need here. So define Pascal row, okay, n. We need row n of this, the nth row, or actually I called it here k. Well, it doesn't matter. It's going to be the same thing. Let loop. Okay, I need to begin with an empty object. And now my counter, I'm going to be incrementing this counter. I start with 0. This counter going to go from 0 to 2n. So we stop. We stop the counter, or we stop the iterations. Stop iterations. So let's stop the iterations. Stop iterations when I reaches 2n plus 1. So at this point, we don't go through any more iteration. We return the row. Okay, let's put that in right away. So when I is 2n plus 1, we immediately return the row. Now, some of you wonder why I'm building row. I'm going to be building this row using const. Okay, let me put that in here. And usually the tradition is always you reverse the row because it's being built backwards. But it doesn't matter in our case because the rows of Pascal's triangle are symmetrical, so it doesn't matter. You don't have to reverse it, just in case you're wondering about that. All right, now, if I is an even number, look at this. When I is 2, I find the binomial coefficient 6, 1. And when I is 4, I find binomial coefficient 6, 2. So I got to const onto it a binomial coefficient. So I call loop, and I const binomial, not I, but I by 2. Think about it, as I just explained. Const that onto the row and increment the counter, like that. That's my call. Now, in this last case, if it's odd, okay, there's no other possibility. The other possibility is odd. I const a 0 onto it. Look, let's look at that carefully. I go here, you see, when I is odd, I const 0. Here, I is odd, I const 0. 0 is even, so I have to calculate a binomial coefficient. But when I is odd, I const a 0 onto the list. Okay, const 0 row and increment my counter, I, 1. Okay, does this work? Maybe. Let's see. Pascal row 6. Let's see what did I do here? Pascal row n. Oh yeah, Pascal has 1a, not 2. Okay. Yes, it works. Great. Beautiful. 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 There is something I'm missing though, and that's paredit. I should turn paredit on and show parens. I should have all of that kind of automatically loaded with Emacs, but I often have it turned off when I'm using latex. Okay, next, what do we got next to do? Well, we have to build these wings here, these paddings. So we need a function that creates a padding list like that. Okay, that's really easy to do. Let's define a function called zeros, and it creates padding given nk. Make list minus nk. Where am I getting that from? Well, over here, look here. 6 minus 2 is 4. Here k is 2. Look here, k is 2. N is 6. That's the total. The largest row is row 6 of Pascal's triangle. You have to keep in mind Pascal's triangle is being indexed from 0 to n. So there's actually n plus 1 rows here. But that's just the way life is with Pascal's triangle. See? Here its index is 0. Look here, second element, here 0, here it's 1, here 2, here 3. That gives us a convenient way to number the rows, but the numbering starts from 0. So, n minus k. Right, so let's go down here, n minus k, and I make a list of zeros like this. Let's load it, let's try it. Zeros, let's make 10. Does that work? Yes, okay. 6, 2. Sorry. There, 4, just like we need. Okay, let's go back here. Let's go back here. Let's see. 6, 2 is 4. Let's test another one. 6, 4. 6 minus 4 should be 2. Padding of 2, right? Look here. See? Padding should be 2. All right, let's try that. Let's try that. 6, 4, 2. Yeah, okay, it works. Excellent, okay. So, next, we got to make this table. And now making this table is really easy now, okay? We're going to make this table. What we're going to do is pad. We throw in this pad. We use append, list append, and we create a 0 list. Then we create this Pascal row list, and we create this 0 list. We append it all together, and we throw it all together in a list. And I'm going to use Racket's for loop to do this because it's really a convenient thing to do, to use. Make table, I'm going to call this make table n. So it goes up to Pascal row n. For list. What does this do? For list creates a list. It wraps whatever body it's computing into a list. So I've got to do it from k is 0 to k is n. K from 0 to n. Now this works like Python range. The range will be from 0 to n minus 1 if I put like this, okay? If I just put like this, it's from 0 to n minus 1. So I've got to add an extra 1 here to get the correct range, okay? Now I append together my zeros, n, k, and I append my Pascal row, the kth row of Pascal triangle, and again, zeros, and k. All right, is this going to work? Let's try to construct our thing that we did here. Here, make table. I'll try to create the same thing I have up there. Make table 6. Yeah, it's exactly the same. You see, take a good look at this. And now let's compare to the thing we have up here. Yeah, that's it. Same thing. I can make a much bigger one, you know. It could be a lot of fun to make bigger ones. Let's try making 10. Ooh, very big. Okay, that's great. That works. And let's continue now to the graphics part. So let's start to learn how to use the pict graphics, which is really cool, really cool. Now, let's make a function, define square. This is going to create a graphic square of some size and color. And it's like this. Colorize, filled rectangle, size, and color. Okay. Let's see how this works. All right. Filled rectangle. Okay, let's fix that. Filled rectangle. Okay. All right, let's see how this works. Let's create a filled rectangle of 100, 200. There. See? Or you could do it like this, 200, 100. There you go. Maybe we don't want black, we want to colorize that, so colorize it. Great, okay. Colorize, filled rectangle, and let's make it purple. Close. There you go. You see how this works? All right, now I have my square function, which creates a rectangle that's got equal sides. And let's make a square of 300, and color is red. Let's see how that works. Yeah, there you go. Now, it's very interesting. I want you to think this over here. Let's create some squares, and you can think about this philosophically. It's quite something to think about. Let's define square size to be, let's say, 50. And let's define some objects. Define even square to be square size. And color is green. Now let me just cut and paste this thing because I need a few more of them. 3 of them, okay. And make an odd square. Odd square blue. I don't know if that's what I said in the beginning, but it doesn't really matter. And a background square to be black. Okay, black. Okay, so let's load up these objects and watch this. If I define a number, or let's say a string S, define S to be the string A, B, C, D. If I now type S, it evaluates the string to, it evaluates S to the string A, B, C, D, but it displays a graphic. What is the difference between this graphic and that square you see above? I don't know. I think the difference is only apparent. You see, now if I type in even square, this symbol is evaluated to a graphic. That's how you should think about it. There's really no difference between an object like S, which is a string, and even square, which evaluates to a graphic. They both evaluate to some kind of graphic, right? So think of it that way. It's kind of an interesting thing to think about. All right, we've got our squares, and I'll show you now how to use append, VC append. Let's see how that works. Okay, let's do VC append. That's going to vertically append an even square with an odd square. Let's try that. Vertically append the two, you see? And if I want to horizontally append them, that's what I can do. Of course, I can do all kinds of combinations of these things. I can horizontally append things that I have vertically appended, and so on and so on. You see? So I can build up some really complex graphics with something like this. Okay. In fact, I can give you an example of this. Define foo is HC append odd square background square and even square. Yeah, very good. Okay, I'm going to make another one, but vertically defined. So let me copy this and paste it. Let's call the vertical one goo and VC append. Okay, great. All right, let's load that up. Now, what does foo look like? There. And what does goo look like? There. And I can actually stick the two together. VC append foo goo. And HC append foo goo. Very cool, you see? I could do some crazy stuff with this. All right. Going back to our Pascal triangle here, I need a way to change an odd number into a colored square and an even number into a colored square, you see? So this number, let's look at this row here. This is going to be green or blue, and this one going to be blue, or and this one going to be green, and this one going to be blue, and so on. And the zero's got to be black. So I need to have a way to change number into a square. So let's define a function that does that. Number to square. Number to square x. X can be any integer. So I'll use cond for this because there's many conditions. First test if it's 0. 0 is an even number, so test for 0 first. Because 0 is even. So test 0 first. Because if you don't test 0 first, your logic is going to be bad. Okay, so if x is 0, then return a background square. And I don't know how we decided above, but let's see. Like, what did we say above? If x is odd, what was it? It's an odd square. Yeah, odd square. And otherwise, any other situation, we have an even square. An even square, Yeah, even square. Okay, let's try this out. And I have error. What's wrong here? I have background. Ah, yeah, background square. I did something silly here. Okay, let's try that again here. There has to be hyphen here. It's good for you to see how errors happen and how we recover from them in Racket. It's good to see. All right, number 2 square. Let's try an odd number, 113. I got something wrong here. Let's see. Number to square application is not a procedure. Why is that? Ah, yes. It's I ended up putting in C here. Okay, try again. Yeah, okay, blue. Let's try an even one. 144. And of course, let's try 0. There, we got our squares. Everything is working according to plan. All right. What's next? Well, let's render the entire row. Let's go back up here. I'll show you what I'm talking about. We're going to take this entire row from here to here like this and render it as squares. Okay? So we're going to compose them all using horizontal append. Define render row, row. Okay, so apply horizontal append, and I have to map number to square to all of these numbers. All right, number to square, row. All right, let's test this. All right, okay, let's create a row first. Pascal row 6. Okay, now let's render this row. Yes, beautiful, and we can make a big one, let's say 10, like so. Yeah. Okay, now we've got to stack these things horizontally. Well, I mean vertically. Yes, vertically. Okay, we did the horizontal stacking. Now we've got to stack vertically like this. So there's one more function we need to do. One more. And I'm going to call this render, as in render the whole Sierpinski triangle of order n. So I'm going to apply a vertical stacking and map render row. I'll explain the logic of this one-liner in a minute. Make table n. Now, this is what I like about functional programming. This is really awesome. It's a one-liner that does an incredible job. Okay, with make table, let's load this, I'll tell you. Make table makes this Pascal triangle table with the background zeros overlaid on top of background 0. Okay. Render the row will render each row of make table because I'm mapping. Map this function onto each row of the table. And then I apply VC append. It takes all of those rendered objects and composites them all together into a vertical assembly. Are you ready? Let's try this, all right? Let's try this. Okay. Render Pascal triangle of order 6 into Sierpinski triangle. There you see. There you see it. It's beautiful. Let's make this a little bit bigger. Let's try a bigger one. How about 10? There. Now, if I make these squares smaller, I can go much higher resolutions, you know. So let's make that square size smaller. So instead of 50, let's make a square size of 20 and run that. Okay, let's try Pascal triangle, 20 rows now. There, you see the fractal structure emerging, triangles within triangles and so on. Okay, let's continue that. I'm going to make it a bit smaller. Actually, let's see what happens if I go to, let's say, 40. Yeah, beautiful. Now, there's a trick I could show you. I'll show you now. If you choose an n as a power of 2, you get perfect results. you don't get this raggedy triangle. You get a perfect triangle, perfect Pascal triangle. Let's go down to 5, and I'll do it with n is 64, and you'll see what I mean. Okay. So let's render with 64 up to 64 rows. It takes a bit of time. There, you see. Look at the bottom of the Sierpinski triangle. It's perfect. You're not cutting any triangles in half or truncating anything. That's because your n is the power of 2. Now I can do, I have a pretty fast computer, so I can render 128. Let's see how that looks. Might take a minute. There you go. That's beautiful. It was a lot of fun to create this. Racket's graphics module is really cool, and it's just what you need to do adventures in mathematics. I'm gonna do more of them. I hope to do things like Mandelbrot, Julia sets, stuff like that. And you should too. It's really, really cool. Okay, if you like this video and you want to see more stuff like this, click like, subscribe, send me a comment, and see you next time.